Hello world. I decided to make a little documentation, a video documentation about a little project that I recently was quite excited about, and that involved flashing Tasmota firmware to one of these cheap Wi-Fi sockets that you can buy. That works pretty much with any device that has one of these ESP chips. So this is one of them. Yeah, and I was really happy after this was successful because, as we all know, these sockets, they come with apps that are cloud-based. So we are pretty much dependent on these servers that are operated most of the time in China. And honestly, I actually already plan to get rid of these plugs or sell them, or because I didn't really want to use another shitty app on my phone. So I was really happy that I found some resources online and learned how to do this. And so a little introduction to this plug. The original name is Lunvon. We always have these funny names for all these plugs. I also don't know where these guys come up with the names for the companies or the product names, but whatever it means, it says Lunvon. But funny enough, I found actually there's another operator behind this. It's called RS-Smarthome. So actually we can download two apps and they both have absolutely the same function. So you create an account, log in, and you can pretty much operate these plugs with either the Lunvon app or the RS-Smarthome app. Just to give you a quick idea of how this actually looks, I'm going to open this app on my phone. So I have the RS-Smarthome, and so here we are. That's the one. So pretty much, it looks like this here, RS-Smarthome. This is the last plug that I still have in my account, just to show it off. And I think after that, I will just delete that app and also delete that device. So now the target that we want is to actually have this operated with Tasmota. So in the end, it will look like this. And we have beautiful functions here. It's not a lot. This one doesn't come with measuring of energy consumption, but we have just a toggle function. We can connect the LED. We can make the button itself work on the plug, and of course the relay. So it all works as it should and as it worked with that Chinese app. And we can just operate this on our own web server at home. So we're totally independent from any cloud service, which is the target. I'm just going to show you quickly what it does. We have a configuration. We do have the MQTT protocol. We have timer functions, which is awesome. So we can set up to 16 timers. It also works with sunrise and sunset. I'm not sure really why these times that are put in here don't really match with my location. But roughly it's okay. So even if it doesn't, this is really great that you have a independent timer in there as well. So you're actually totally independent from any platform, and you can just open your browser and control the plug from there. And of course you can integrate that into your Home Assistant as it supports MQTT. So I would say let's get to it, and we'll start with the actual documentation. Great. So here we can see a different view. We're going to switch the view from hardware to software sometimes, depending on what is the focus at the moment. I have prepared a little cue sheet so we can see the structure of the tutorial and the steps that we are going to do. Basically, it is divided into 5 steps, starting with preparations of the software, then preparations of the socket itself. Third step is connection of the devices. Number 4 would be to actually flash the chip, and number 5 is the setup. We start also with prerequisites, so what we are going to need for that, and also have a little test in the end to see if everything worked as we planned. So let's start with the prerequisites here. So of course we need the socket itself. This should also work with any other socket that comes with the ESP82 chip. And we need a torx T8 bit. This is a security torx bit, that one that has the little hole inside. We need a soldering iron and some basic soldering equipment, just some solder wire, some flux, and yeah, some copper, some small copper wires. In this tutorial, we're going to use a Raspberry Pi. So I decided to use that because I have one handy. If you don't have that, there are other hardware options where you can flash, but I took the Raspberry Pi 4, as I have one here that I currently don't use. And yeah, as I mentioned, some jumper wires, really thin ones. So that is the pinout connection wire. Oh yeah, that is the wire that you actually plug on the pinout of the Raspberry Pi. And you can put that into a connection board, or you can just wire any of your tools on there. Yeah. And of course, we need some sort of network connection. I use the Wi-Fi here. It's pretty convenient. But of course, we can use cable too. Okay, so let's start with preparing the Raspberry Pi. We just choose the Raspberry Pi imager, choose the smallest image and put it on an SD card. So I have a 32 gig SD card here. We can preset a host name. This is very important. We have to enable SSH to be able to communicate with our command line interface. Of course, we would need to set a username and password to log in there. And here you can see my Wi-Fi SSID. So yeah, that's pretty great that we can prepare everything. So as we plug in the SD card in the Raspberry Pi, everything boots up and should be ready to go. So while this is happening here, we can use the time to actually start preparing the plug itself. Okay, so this one is not so successful, but yeah, this is a torx, security torx T8-bit. Yeah, no comment here, we cannot really see it, but I wrote it earlier, so you probably know how they look like. Again, we have the plug here, so there are 2 screws that we need to take out, and that's, yeah, it's not rocket science, works easy, just unscrew them and then that thing will pop up right open. Around this point it would also be a good time actually to start heating up our soldering iron so that it is already nice and warm and we don't have to wait when we actually need it later. Let me also quickly mention that we're going to need a 3.3 volts power supply for the flashing process. Now the Raspberry Pi does have a 3.3 volt outlet. I'm going to use this one for this tutorial. However, if you have any problems with that, it is widely recommended to actually use an external 3.3 volts power supply during the flashing process. Okay, so let's have a look how that thing looks from the inside. It's just a small PCB with a relay, and it's attached with 2 or 3 thick wires to the socket plug, which we don't have to remove. We just try to wiggle our way around so that we somehow have the most convenient access to the solder points. Of course, it always depends on the structure of your device, so you might have to totally desolder the PCB from your housing in order to be able to reach all the solder points in a convenient way. Now, as we have some progress here, meanwhile, let's take out the SD card, plug it into the Raspberry Pi, boot that thing up, and let's do some work on the software side of the project. I'm going to already prepare the microscope camera for you guys so we can have a look later at the soldering. And we are using PuTTY to communicate with the console and FileZilla later for file transfer. So let's start to put our host name or IP address here. In my case it's this one. Port is 22. And let the magic happen. Of course, for some reason it doesn't work right away. I'll try that again. Sometimes it just takes a while, and I was not patient enough here. So with a little bit patience, sometimes things are just easier. And here we are. There it is. I basically didn't do anything else, just waited. And after a while, with a few attempts, it worked. So we remember the username from before. That was /ESP. And our password that we put in there. And there we go. So we have access to Raspbian OS, and first step is always to get some updates and do the upgrade. So we finished the installation of the OS. We got our connection to SSH via Wi-Fi or Ethernet, and we are doing the updates. And while this is happening, we can actually take a little glimpse into step 2 already, which is to prepare the socket. Now I got my microscope ready, and the first thing I want to do is take a good look at the chip, just to make sure it is actually compatible with what we want to do. So if you have the same chip that says ESP8285, then you're good to go, and Tasmota will actually work with your device. And we're going to have a look at the little solder pins that we are going to connect the wires to. So we have 4 pins here. We see the bigger ones to the right, 2 of them. These are voltage and ground. So this one here is for ground, that one is the 3 volts, and here is RX and TX port. So those ones are the 2 data ports that we will use to receive and send data. Other than that, the view on the board is not so interesting. We can see the power button here. Yeah, it depends on the architecture of your device. Make sure that you know where your connections are. Yeah, so again, ground to the right, followed by 3.3 volts at the left-hand side, and then that next one is the TX port. So that means here you have to connect the RX port from the Raspberry Pi, and the one at the very left-hand side is the RX port. So we have to connect the TX port of the Raspberry Pi there. Little comment on that. If we are going to mix them up, the TX and RX, it's not the end of the world. Nothing is going to happen except that, yeah, literally nothing is going to happen because we don't get any communication. But yeah, if we take good care, we can do this right the first time we attempt to do it. So on the very left, connect the TX port of the Raspberry Pi, and the second one on the left hand side, connect the RX port of the Raspberry Pi. What we really don't want is to mix up the ground and voltage, so make sure the ground connection is on the very right and the 3.3 volts are on the second one from the right hand side. So here I am following up with the process to get it all in order. So this is where we are right now. We have just updated, and the next step would be to install software named ESP tool on our Raspberry Pi OS. So first thing we want to do is install pip, because I got curious what actually is pip. I just found it out because that's what I needed to get it running. So if we Google that, we'll find out that pip is a package management system that allows you to install Python packages. So that's what we need in the first place. Okay, so after that, let's get some packages that we need. Just copy the commands from the description. Hit enter, confirm. It should be around 300 megabytes that are installed, so make sure to confirm the rough size, depending on your setup, of course. And the installation should not take too long for those packages. Okay, so once the installation is finished, we actually can install the ESP tool now. So with all those preparations, there should be no error message. The important step is to install the pip first, and then all the packages, and then the actual ESP tool software. And this is going to take a while, actually. So while this is running, I am switching forward to step 2 and continue with our preparations of the socket or the module in the socket itself. So what I did is I attached really thin fly wires to some scrap wire that I just found from an old power supply, just soldered them onto each other so that I get a reliable connection to the solder points of the PCB, which are quite small. So these fly wires here that I use, I'm going to tell you later what diameter they have, because I need to look that up. But you want to take something that is really not too large, not too thick, so that you can actually have a connection without bridging other connections that you don't want. Because with all these small, with these sensitive PCBs, just one short is enough to damage the whole thing. Yeah, so I looked it up. The wire is actually 0.1 millimeters thin. It's just, yeah, basic copper wire coated with enamel, which is perfect for permanent repairs. I just use that here to have something that is small enough to, yeah, connect and bridge these connections here. So let's put some flux on the solder pins here. And we're starting with the RX port. Pretty straightforward. Looks okay. This is not, doesn't have to be perfect here. All we want is to have a solid connection for one-time use, because we're going to disconnect it after we're finished with the flashing process. There are probably other methods of making a connection. Maybe there are like super tiny little clips that you can just attach there without soldering. But yeah, as I had all that equipment here, I just decided to go with what I have, and it doesn't take that long. So this one is the 3.3 volt connection. Again, to make sure. That doesn't look so good, but well, maybe it's good enough. So the last that we still need is the ground wire. So as these wires are coated, there can't be any, there's no problem even when they interfere with each other. There's a microcoat around them. So that's why I attached those wires before already to bigger wires, so that I can actually have something on the other side that I can put a clip on. So this looks good enough for me to run the connection here. Just double check if, in case they're loose, we have to do it again, or one of them again, but they all look okay-ish, good enough to go forward. So back to our installation of ESP tools. This is actually the step that takes the longest time. It builds cryptography here. I am not that deep into that matter, so basically what I did is also just followed the steps that I found on the websites, and yeah, solved one or the other problem, so that all what I do here should also work for you. Probably we don't need to be able to explain every little step or what's behind that. We're just happy if it works in the end. And yeah, whatever that cryptography here is needed for, I don't know, it takes a lot of time, but in the end it worked. So let's see where we are in our process. We have installed the ESP tool. We already prepared actually everything of step 2 at the same time. So yeah, this is great when we do both soft and hardware operations. While one of two things takes a while, we can take care of the other thing already and already have 2 steps solved at the same time. So we already did solder the wires to the pins. Here, to get it in order, this is step 2. Oh, and we are not finished with step 1 yet, because we still need to make some adjustments to our configuration. Oh yeah, that's a good idea. I will zoom everything a little bit bigger so it would be easier to follow, in case some of people's resolutions are not great, so they would still be able to read what I'm typing here. Oh yeah. So I have to configure the setup of Raspberry Pi OS a little bit. I have to adjust the command line txt file. So I suggest to make backup copies first. So in that file, we want to delete the first entry, which is not that hard. That is already done. So next we are going to edit another file that is also in our boot directory. That is the config.txt, and we want to add something very important at the end of this file. We want to enable the UART so we actually can get a connection and we would be able to see the device when it's connected to the TX and RX pins. Next we need to disable some services. And we have different options for different versions of the Raspberry Pi. So if you are on another Raspberry Pi, an older one, then this is not working. you need to change the command here because it's not saying TTYS, but it's saying something else. This is all this information you will get from one of the websites, and I will also put all the websites here so you can follow up. Okay, so we disabled and stopped the service and rebooted. And here we're back online. Okay, so enter credentials. And let's see what is the next command. Okay, I'm going to test if the ESP tool script actually works already without having anything connected, because we would get error messages anyway if there's no connection, but we can already see if there's some sort of response. And what happens here is there is something totally wrong. Maybe you already have spotted it. At the time I did that video, I did not know what's the problem. Try to figure it out, but yeah, it's pretty obvious actually. I just mistyped here because it's not SSY S0. It should be the device should be addressed with TTY S0. So yeah, here I'm checking again if all the config files are still okay, or if there was something wrong with saving them, or but yeah, seems to be all fine here. Also here the entry is still like it should be. So this is another thing that helped me when I tried this setup the first time, to upgrade the pip packages. So it actually does something here. It downloads some update and installs it. I don't know if it's really necessary at that time, but yeah, I did another reboot to make sure everything is started correctly. But yeah, this is what happens sometimes when you're not doing this every day, when you're not a coder. You just don't have your eye just doesn't catch all of these flaws when it should. So yeah, this is just typical learning process. Just make sure everything that you type in the command is exactly as it should be. And then most of the times we are happy in the end. So I think now should be the time when I spotted the error. Yep, so here I go, exchanging these two S's with two T's and starting, and I get another response here. So it's starting to connect to the device, but because there's nothing attached yet, I get the error message, but at this point, this is what I wanted. So I knew I could go move over to the next step and actually hook up the Raspberry Pi pinout system to the 4 pins that I connected the solder wires to. So finally, we're going to this step, and yeah, this step is pretty straightforward. It's just all about hooking them up. So whatever setup you have there, just make sure the connection is established. It doesn't matter if you solder everything together, or if you have clips, or if you have one of these breadboards and plug the pinout pins in there and you have more pinout pins. I just had a couple of these pinout pins, so I had to just take what I have here. So yeah, I just took these clamps, some scrap wires that I took off an old power supply. You know, just get your voltmeter ready to double check if all the connections are made. So let's move over to the workbench here. And here you can see I have different colors for the different pins. The purple one is where the Raspberry Pi's TX goes, so that if we remember, that was the very left that we saw under the microscope. So purple is TX Raspberry Pi, yellow is RX of the Raspberry Pi, red is 3.3 volts, and black is ground. So yeah, they look a little bit like fingers on the table there. So here I have my board already prepared with the pinout wires. As we can see, the coloring doesn't really match, but as long as we know what we're doing, we are fine. Only thing that matches is the red one. Let's have a look at Raspberry Pi 4's pinout organization. We have 3.3 volts on the upper left, number one. We have a GPIO 14, which is TX, so this is the sending channel. We have the GPIO 15 with the number 10, which is the RX, the receiving channel. Then we have some ground above, and in the end, yeah, we have another ground here. In the end, I decided to take the ground number 39 on the bottom left, because it's just that one that is the furthest away from the voltage pin. So yeah, less chances of troublemaking. So let's get to it. I just took some basic clamps here. This one goes to the ground. Let's try to make this as far away as possible from the volt. So my ground wire on the Raspberry Pi is yellow. On the switch itself, it's black. And of course, so all the confusion is perfect. The colors of the clamps are also kind of random. I just try to, match them up as good as possible, or as best as it made sense to me, so I could remember which one is which. So the yellow one of the switch is the TX port of the switch. So this is where the RX of the Raspberry Pi goes. Here I prepare the volt pin already. I have it on my helping hand here. To make sure it's just in a fixed position and doesn't send little electric shocks anywhere that I don't want. I know this all looks pretty funny here, but yeah, it actually worked pretty well. I didn't have any trouble with shorts or not working sockets. It all worked pretty well. Yeah, let's hook up the 3.3 volt already. So the purple one goes into the white one, and the white one goes also into the white one of the Raspberry Pi. So purple one of the switch goes into the pin 8 of the Raspberry. And here I test if there's any reaction, and it is. So we have power, and what we have to do now is press down the button, then directly connect the power, hold the button for 10 seconds, and then release it. So we enter the flash mode on our device. For that we already need the connection, so all these steps are, yeah, they kind of depend on each other, and they depend on the setup, the hardware setup. We're going to back up the original firmware that's on there in case we, for any reason, decide to go back to the Chinese servers. Then we are going to erase the chip and finally write Tasmota firmware to the chip. That's actually pretty much it. It's not that hard. So, in order to enable the flash mode, it is necessary to press down the on-off button and then hook up the voltage. And we have it pressed for about 10 seconds. So that's what I'm doing here right now. And we don't see any reaction of the board. The LED is not flashing. So if nothing is happening on the board, that's a good sign. Now, let's back up the original firmware. For that we need our ESP tool script. I just paste the command here. The important part now is to specify the file name that I want. I chose Lunvon 1.bin because I have several plugs, and I gave each backup a number. And I can see right now the green light on the other screen there just came on and it starts reading. So connection is working, the script is working. Yeah. We are just in the home directory of our user /ESP. So we got the firmware file, the original firmware file, saved here, as we can see. Oh no, we can't. I have some problems with the connection here. I honestly don't know why FileZilla gave me trouble here, but yeah. In the end, I just had to restart it and it worked. So maybe it was the wrong password. I don't know. Nope. Let's give it a restart. And while we're at it, we can see the firmware is almost finished with reading. And we're done. Good. So let's restart FileZilla. There are various ways of transferring that file to other places, to store it, to keep it safe somewhere, but I decided to use FileZilla because that one was the fastest for me. So start over, sftp : // IP address, username, password, and port, and successful. So we can see we're in our flash ESP home directory. We have the lunvon1.bin file. This is what we wanted. I drag it over to my Windows file system, and at the same time pull over the new firmware that I want to flash. That one is compressed in a GZ compressed file, so we need to unzip that first. Okay, first I erase the flash. By the way, we can see the green light there that came on as soon as we started interacting with the chip. And that is a good sign. It means power is there. And as we didn't have any error messages, the power supply also is sufficient. We use g-unzip tasmota.bin.gz. So we see now it has been converted into a bin file, tasmota.bin, and that's what we now want to write on the chip. So we use the same command as before. Just change the file name, and we want to change read flash, of course, to write flash. And I think at the first attempt that didn't work because that is not enough. So let's quickly jump to the website where I found the files, which you can see here. So just download the file that matches your device. There are different versions for different devices. Mine was just a standard tasmota.bin.gz. So as you can see, there's an error message here. And I also did not a great job with aligning the windows, so we cannot see the full line here. There's a little part on the right hand side that's cut off. So worry not, I have all the information we need posted below in the description. I thought it was easy to just replace read with write and then specify the input name for the firmware, but that was not enough. There are some other parameters that need to be set, and as I said, you can find them in the description where the correct command list is put. And with finishing of writing the firmware on the chip, the biggest part is done. That's the Raspberry Pi. All that we needed to do on the Raspberry Pi is done now, and we can move over to the next step, which is actually restarting the device and testing if Tasmota actually starts up and gives us a new Wi-Fi access point. Step 4 is done. We entered flash mode, we backed up the firmware, we erased the chip, and we wrote Tasmota firmware to the chip. And we can right away start with configuring Tasmota. We still use the voltage that is connected to the socket. We don't have to assemble it again right away. We can first check if actually the firmware is on there and reacts the way we want it. So as soon as I reboot it, as soon as I disconnect the wire and connect it again, it should be blinking, flashing green, and I should be able to see a new Wi-Fi access point. Okay, it's not flashing, but maybe that is also fine. I don't really remember what behavior it should have, but let's see. Okay, let's check the Wi-Fi networks. This is my network, and we have the Tasmota network here. Let's connect to it. We choose only connect this time. We go to the settings of the network and we go on manage router, and we should get this IP address 192.168.4.1, and here we can configure already the details of our home network, SSID and password. Hit save. So the device can reboot, and you should get a new IP address if you got DHCP enabled in your router. As we can see here, I got a new one with 117 in the end, and it's showing me that it's also a successful Wi-Fi connection. So we need to configure the module, because at this point nothing works. There's no reaction to the on-off button, so we have to change the module type to generic. And what I'm doing here is wrong, so don't do that. Just leave everything at none and then just hit save. And the device should reboot one more time. Yep, so it will look like this. When we have a generic, there's all the GPIO slots there. So the ones that we need to set are the GPIO O for the button, the GPIO 9 for the LED, and GPIO 10 for the relay. And once we assigned all these GPIOs to their functions, we're all set. The device reboots one more time. And it should work right away, as we can see here, on and off, and LED and relay should come on and off as we toggle the switch in the web interface. So now we can go back to assemble everything back together, disconnect the wires. And once it's assembled, we can run a final test. Okay, short recap. What did we do? To repeat the steps is always good for our memory. So we connected to the new Tasmota network after the flash process, and after reconnecting, then we entered our Wi-Fi credentials there. We set the device type to generic. And finally, after restarting, which is important, we enabled button, LED and relay on GPIO 0, 9 and 10. So I want to use this time while I do this here to say thank you to all who actually prepared all the information that I needed to do this. So there were these few websites that I found. Of course, first thank you is to the guys who made Tasmota. It's a great interface. So then, yeah, I just want to thank all the people who made these websites, who put the information out there that I basically just found with Google and searched together, and then just followed the steps that I needed to do. It's always a great feeling if you have a project like this and in the end it's successful and you can actually make use of the devices that you actually thought are useless or you didn't want to use them anymore. But with some stuff like this, there's a whole new world of options, such as, yeah, using all these plugs. Now I still have seven of them. So I have 7 plugs that I can use in Home Assistant. Which is awesome, because before I was dependent on that RS-Smarthome or Lunvon app, and I don't need that anymore now. And I don't even need an internet connection. I can just control all these plugs in my local network. So a step towards more independency. I have to make a little update comment, which is unfortunate. I found that one of the websites that I used, actually the most important one, is not online anymore. I don't know why. I hope there's a alternative in the future. It was actually linked in linked on the website where I found the compatibility list for Tasmota, where I also found this Lunvon plug. So there were two links. One of the links had some photos with a description of how to connect the wires to the pins. But yeah, that one very, very helpful website is gone, unfortunately. I found another one that seems to be an older version of it. It is pretty similar, so a lot of important information can be found there. I will also attach it in the description. I hope, I understand that, of course, this is a plug that not everyone uses. Probably most of you have different models by different companies, different brand names, but the process should be the same. All you need to do is make sure that you get the connections right. So find out where is the voltage connection, where is the ground connection, and where are the transmitting and receiving pins. I think a lot of information can be found on the Tasmota websites, because there's a huge list of supported devices, and there's a fair chance that your device will be supported too, and the process of writing Tasmota to the chip is basically the same. I'm going to say it again, just make sure that you don't mess up with the voltage. Don't put 5 volts to where 3 volts belong, because that literally will mess up your device. So just be careful with the connections. Okay, let's try it out. So I plugged it in, it started flashing and came off. The LED is turned off because the state is also off. So let's see what happens. Oops, yes, that looked good. I switched toggle and it changes the state from on to off. Here again the overview of the 3 ports. I think it was not very good to see, so I turned off the light to show it again. Turning it on and off works beautifully. All right, so yeah, I hope that I could help anyone who has similar ideas. Thank you for your attention and have fun.